Students, welcome to the video session. Now in this video, I'm going to discuss the problems on moment of inertia. I'm going to discuss now. Okay. Here, before solving the problem, that is, one should know what are the formulas are involved in this. The formulas and also the units are required. That's why. Here, first one is omega equal to 2 pi f. What is omega? It is angular velocity. What is f? Frequency. Sometimes frequency will use like this, number of oscillations per second, RPS. Sometimes you use that is in terms of what? RPS, that is rotations per second, or else sometimes it is what? RPM, like this. If it is RPM is there, then you have to convert into what? RPS. By dividing what? 60, you have to convert it. And what is the unit of this is? The unit of this one, omega, is what? Radian per second. Next, alpha. Alpha is nothing but angular acceleration. Here, angular acceleration equal to omega 2 minus omega 1 divided by what? T, that is omega 2 minus omega 1 divided by what? T. Okay. Here, the unit is what? Radian per second square. Next. Here, that is very important formula. It is torque equal to what? Torque equal to I into alpha. What is I? Moment of inertia. What is alpha? Angular acceleration. The equivalent unit is what? Newton meter. Or sometimes they will write joules. Also they will write. Because the equivalent unit of torque in linear motion is work done. Here, another important formula is L equal to what? I into what? Omega. L equal to, what is L? Angular momentum, that is angular momentum equal to moment of inertia I into what? Angular velocity. The unit is what? Kg meter square per second. And another formula is there for the L also, that is L equal to, that is momentum about a distance, mv into what? R. M is what? Mass. V is the what? Velocity. And R is the what? Radius. What is the unit here? kg meter square per second. Okay. Now with this, with this idea, now let us begin with let us begin the how to solve the problem status. Before that, and also you studied in the syllabus, moment of inertia of a ring you studied, moment of inertia, circular disc you studied, moment of inertia of what? That is solid sphere you studied. The different cases will come and in these cases, in each case. Now, first one is circular ring. If you don't know this formula, you cannot do that. And also, one should know the parallel axis and also what? Perpendicular axis theorem also. Now, I'm recapitulating all the things. Now, I'm recapitulating the whatever we discussed in the theory class. I'm recapitulating those things now. Okay, students. This is the formula for the what? It is axis. There is a circular ring. Now it is axis is what? Passing through it. Now the body is what? Rotating like this, either clockwise or anti-clockwise. It is rotating. About this axis, it is rotating. Listen, see here. About an axis, that is about an axis passing through center of gravity. Sometimes we are writing it is what? Center of gravity. We'll write CZ in the problem also. CZ means center of gravity, that is, and perpendicular to its what? Perpendicular to its what? Plane. What is the formula? I equal to mr square. Students, of course, there are different various and nearly about 4 formulas are there in the circular ring and also in the disc and also what in the lamina and all that. I will tell you one easiest method how to remember this. I equal to mr square. Remember, for the circular ring. Next, for this, you say, another case. Here, I think you can understand that about the axis xy. Xy is a tangent to this. Xy is a tangent to the what? Ring, that is. In that case, what happens is, you should remember, it is these two are parallel axes. Which are the parallel axes? AB is AB and also what? XY are the what? AB and XY are the what? Both are what? Parallel axis. Now I know the formula for the parallel axis theorem here. Moment of inertia about XY equal to IAB, nothing but what? Moment of inertia through the center of gravity, that is through the center of gravity. This is the formula. This is the formula. Because why I'm writing the center of gravity is because it is passing through what? It is passing through its what? The center of gravity. The axis is what? Passing. So that this formula will be what? mr square. IAB is nothing but what? mr square. Plus, you know the formula for the parallel axis theorem here? One is ICZ plus of what? mr square. That is the formula for the parallel axis theorem. Recall it, very, very important. Sometimes they ask the question, state and explain the parallel axis theorem and perpendicular axis theorem. It is mr square. Why I am writing mr square is here distance between these two axes is what it is r here. That's why mr square plus mr square equal to what? 2mr square. This is one case, two cases. Next one is, but remember student, here tangent is the no, that is many times it creates the confusion about a tangential axis perpendicular to its plane. That is more important. Okay, next one here, that is here circular ring, third case, about its diameter, about its diameter. It may be like this. It may be like this. This is the diameter. This is the diameter. Or else I can take it like this. Either you can rotate about this axis, you can rotate, or else you can rotate about this axis also, you can rotate it here. Both are same. One is Ix. If I rotate it in this direction, this will be what? Iy it is. Okay. Here I'm using perpendicular axis theorem. I'm using here perpendicular axis theorem. The theorem, that is formula for the perpendicular axis theorem is what here? Iz equal to Ix plus Iy. What is Iz? Iz is another axis which is perpendicular to both Ix and Iy. It is perpendicular to both Ix and Iy. It is one. Okay. It is perpendicular to both. This is the z axis. Here, this I will call it as a what? Iz. Now, what is the formula? Iz equal to what? Ix plus Iy. But remember, students, here, whether you are rotating about this axis or about this axis, since the mass is same, the radius is same, so that Ix equal to what is this? Iy. That is. When Ix equal to Iy, then can I write like this here? That is Iz equal to what is this? 2 of what? Ix I will write. 2 of I. Then what is Ix? Ix equal to Iz divided by 2. Divided by 2. What is Iz? Iz equal to, it is axis in the previous case I studied. This is equal to mr square divided by what? 2, that is. Iz by 2 equal to mr square by 2, that is. Okay. What you should remember here in this case here, because here about any one diameter, whether along this diameter or along this diameter. What happens is, apply this logic for all the cases. Whatever that is what we are getting now here, that is whatever we are getting now, it is passing through center of gravity, that is off of it we are getting in this expression. Mr square by 2. Next one is here. About a tangential axis. In the previous case also tangential axis is there. But see, that is here. Axis PQ is, it is like this. In the plane of this, in the plane of the ring it is there. This is in the plane of the what? Ring it is there. In this plane here. This plane. And this is what here it is. About the what? diameter. Diameter. How these two axes are parallel, that is. I know that using parallel axis theorem, I know that. What is that parallel axis theorem here? You IPQ equal to I of xy. It is what? About this diameter. That is plus of what? M_r square. What is I of xy? Just know if you calculate along the diameter, you calculate here. What is this value here? M_r square by 2. Plus of what? M_r square. Why it is r square? Because the distance between them is what? The distance between these two is what? R here. That's why I have written what? This distance between them is what? R here. That's why it becomes 3 by 2 M_r square. Okay. Otherwise, you can't do the problems on this. Okay. Once again, I recapitulate the moment of inertia of the circular ring about an axis passing through center of gravity is what? About an axis passing through center of gravity equal to what? M_r square. And this is the what? Tangent, no doubt, but it is perpendicular. See the figure, how it is. Then this formula equal to what? 2 M_r square. This value plus of what? This value. Using what? It is not perpendicular. I made one mistake here. It is not perpendicular axis, but this is it is parallel axis theorem that you have to apply here. That is, it is not this one. It is a parallel axis. It is parallel axis. Okay. This is M_r square, and this is what? It is M_r square. Both it becomes what? 2 M_r square. Next one about its what? Diameter, that is diameter. Then what I told you about the diameter means what? Here both how they are, this one and this one how they are perpendicular. That is, so both are perpendicular. That is what? Okay. 1 minute. Okay. Now, what is the formula for this? The formula for this is what? M_r square by 2. And formula for this, of course, is a tangent, but in the plane, in its own plane. In the previous case, it is perpendicular, but here it is not in its own plane. It is 3 by 2 M_r square for the circular ring. Similarly, for the circular disc, you say. For the circular disc, I think easily you can understand here. Here, this is the disc where it is rotating about this axis. It is rotating about this axis. It means it is passing through what? Its center of gravity of the disc here. What is the formula for this? I equal to M_r square by 2. See, about an axis passing through CC and perpendicular to its what? Plane here. Formula is what? M_r square by 2. Next. Okay. Now you see in this situation, here, of course, this axis is passing through what? XY. But now, about this axis I'm talking. About this axis we're talking. About this axis. What is this axis here? PQ. See here, this PQ and XY, how they are parallel. But I am interested in calculating about PQ. How the PQ is tangent. And also what it is? Perpendicular. About a tangential axis perpendicular to its plane here. Which theorem you have to apply here? Parallel axis theorem. Then I of PQ equal to M_r square by 2, because just now I discussed in the previous case here, it is M_r square by 2 plus M_r square equal to 3 by 2 M_r square. How it has come here? Ixy M_r square by 2. Just in the previous case, already we discussed, this value is what? M_r square by 2 is there, no? Next. Okay. Now, about its diameter. This is the diameter. About its diameter. It may be like this, or it may be what? Like this. Whether you are rotating about this axis, you can rotate, or else you can rotate about this axis. Always the moment of inertia will be what? Remains same here. What is this value? About its diameter is whatever the value you are getting for the center of gravity now, off of it. That means it is mr square by what? 4. That is mr square by 4. In the previous case, you are getting how much? Mr square by 2. Off of it, that means what? Mr square by 4. How it is? I told you. It is using perpendicular theorem. Iz equal to ix plus iy. But Iz equal to what? Ix plus iy. About this axis or about this axis, both are what? Same here. So that moment of inertia about its diameter, about its what? Diameter. It may be any diameter. It may be like this. It may be like this, or else what? About this diameter. It becomes what? mr square by 4. Next. Okay. Next one. Here, about a tangential axis in its own plane, not perpendicular, in its what? Own plane and all that. Okay. Now, students, about this angle. And this is the what? About its diameter. This is the what? About its diameter. I am interested in calculating about this one, that is about this axis. How it is? Tangent. In its what? Own plane. Then I'm using which theorem I'm using here? Parallel axis theorem I'm using. So that I of AB equal to I of this, that is xy, plus of what? mr square. What is I of xy? Just we calculate here. Mr square by what? 4. Plus of what? Mr square. It becomes how much it is? It is 5 by 4 mr square. Okay. In each case, there are 4 cases are there. Next. Another one is solid sphere, that is solid sphere. You take any cricket ball or something. Solid sphere. Here, this solid sphere is rotating about this axis. It is rotating either clockwise or anti-clockwise. Then the formula for this is what? The formula is it is IAB equal to 2 by 5 mr square. Just you have to buy it at surface. To buy it. Next one is here. Now I am interested in finding about this axis. How this axis is? It is a tangent. About a tangent. This is what? About a tangential axis. And now I have to use the formula. Which formula I have to use here? The axis is there now. This axis, this xy, and this one, that is both how they are parallel now. I'm using what? Parallel axis theorem I'm using. What is the formula for the parallel axis theorem here? We know that. About xy, I know this. About xy, I know this. About xy, I know that. What is the formula for that? 2 by 5 mr square. Plus of what? Mr square. Why I'm using mr square here? Because distance between them is what it is? R here. Distance between them is R here. That's why I'm using 2 by 5 plus mr square equal to, what is this value? It is 7 by 5 mr square. Okay. Now I discussed all the different cases I discussed here. Now let us proceed for the problems one by one. Okay. Once again, what are the formula for this? Omega equal to what? 2 pi m. Alpha equal to what? Omega 2 minus omega 1 by what? T. Torque equal to what? I alpha. L equal to what? I omega, that is. Okay. Normally, your form of problem is calculate the torque or calculate the angular momentum. In each case, you need to calculate the what? Moment of inertia of a particular case. Okay, problem number 1, I'll discuss it. Oh, listen, see carefully now. Here, 3 rings each of mass, 3 rings each of mass m and radius r are arranged as shown in the figure. Calculate the moment of inertia about the axis x dash. Student, first This is what ring that is. This is the what ring here. How many rings are here? 3 rings are there. Now I will call it as a ring 1. I will call it as this one. Ring 2 I will call it. This is what ring 3 I will call it as. Students, you look into here. With respect to ring 1 here, with respect to ring 1, you see, this axis is what? It is passing through its what? Diameter. It is passing through what? One of its diameter. I think you understood this. Then, with respect to what? Disk 2, you see. Disk 2, this axis is there, no? This axis is a tangent. It is a tangent. It is a tangent. Not only to the circle 2, even for the circle 3 is also, this axis is a tangent. How many cases are there? One is what? Diameter. With respect to this, it is what? Diameter. It is what? Diameter. This is what? Tangent in its own plane. Tangent in its what? Own plane. I think this is the third and fourth case, moment of inertia. What is the formula for the moment of inertia of diameter? Is it one? Okay. The ring it is. No, this one. Okay. Ring. Okay. About its diameter. What is the one? Okay. About its diameter. What is the formula for this? mr square by what? 2. And what is the formula for that? It is tangent. PQ is the what? Tangent. What is the formula for this? 3 by 2 mr square. I'm using this idea. I'm using this. Here you see. What is the formula for the about its diameter? mr square by 2. What is the formula for the tangent? That is what? 3 by 2 mr square. Okay. For this, it is for this ring, it is mr square divided by what? 2. For this, it is 3 mr square divided by what? 2. Even for this also, it is 3 by 2 mr square. Okay, next. Now I'm writing the formula for this. I equal to, what is the formula? I is a moment of inertia, is a scalar quantity. Moment of inertia is a scalar quantity. Okay. I equal to I1 plus I2 plus of what? I3 is there. I1 equal to, what is the formula? Just now I told you, mr square by 2. mr square by 2. That is for this, it is mr square by 2. For this, it is 3 by 2 mr square. It is 3 by 2 mr square. Then here mr square by 2 is a common factor here. mr square by 2 is a common factor. So that it is 1 plus 3 plus 3 equal to what? 7 by 2 mr square. What is the moment of inertia? It is kg meter square. Why it is kg meter square? Moment of inertia equal to what? Mass into square of the distance. What is the mass unit? Kg. Distance unit is what? Meter. It is square is there. It is, that's why it is called as kg meter square. Okay. That's very interesting problem it is. Next. A grindstone is weighing 30 kg, has a radius of what? 20 centimeter. Okay. Radius has given and mass is given, and it acquires a speed of what? 100 rpm from rest. That is more important. In 10 seconds, calculate the torque acting on it. Read carefully. Grindstone, nothing but what? It is a disc. It is nothing but disc. It is disc. This is the disc. This is the disc. And it is rotating about this axis is rotating. Just like floor mill, you can imagine this. It is rotating about this axis. It is rotating. It rotates like this. First thing is, you should have an idea of what? It is a grindstone. Grindstone, nothing but what? It is a disc. It is rotating about what? And its axis is passing through its what? Center of gravity. Then what is the moment of inertia of the disk about the axis passing through center of gravity is a mr square by 2. Mr square by 2. That is, axis is passing through its center of gravity. See? Yes. Not this. This one. It is. Is it not? Mr square by 2. About the axis passing through its center of gravity. Next. Okay. Next. What are the other given parameters in this situation here? Here radius has given and speed omega 2 equal to what? 100 rpm. Omega 1 equal to 0. Why I am saying omega 1 equal to 0 is because initially it is at what condition here? That is rest condition. What is the time here? 10 seconds. Now, just what are the given data? Now, mass equal to 30 kg. Radius equal to 20 centimeter. 20 centimeter equal to what? 0.2 meter. Initial angular velocity omega 1 equal to what? 0. Why it is omega 1 equal to 0? You see in the problem what he said here? Rest. From the what? It is rest he told. Now this is what? Rest. That's why omega 1 equal to what? 0. Omega 2 equal to what? 100 rpm is there. RPM you need to convert into what? RPS. For that divided by what? 60. Then it comes around, it is how much it is? It is 5 by what? 3. This 0 get cancels. 5 by 3 RPS. This 5 by 3 I am converting into in the radians. It is 5 by 3 into what? 2 pi. Okay, omega 2 is what? Now I need to calculate what? Torque. To calculate the torque, what is required here? I is required and alpha is required. How to calculate alpha here? Alpha equal to omega 2 minus omega 1 divided by t. We know this formula. Rate of change of angular velocity equal to 10 pi by 3 minus of 0 divided by 10 equal to what? Pi by 3. Okay, you calculate alpha. And what is the moment of inertia of the disk? Because you're talking about disk. When it is a disk means and axis is passing through its what? Center of gravity attitude. This is your disk. It is like this. And it is passing through its what? Center. It is what? It is passing through. It's a center. Now, using the formula mr square by what? 2. Now substitute all these values of m is what? 30 into what? Radius is 0.2 square into this becomes what? 0.6. Now I know the value of I know the value of alpha. Torque equal to I into alpha. I value is 0.6. Alpha value is 5 by 3. It becomes what? 0.628 Newton meter. Okay. Third one. Calculate the calculate the angular momentum. Angular momentum. What is angular momentum? Calculate the angular momentum of an electron. Angular momentum nothing but L. Around the nucleus of an atom, if the radius of the orbit is 0.52 angstrom, you need to convert angstrom to meter. And the velocity of the electron is 4 into 10 to the power of 6 centimeter per second. See, it is centimeter, don't use directly. You need to convert into meter per second. And mass of the electron is so much. Okay, students. Angular momentum, nothing but what? L. L equal to momentum about a what? Distance. What is P? Linear momentum equal to mv into what? R. We should know the value of what? We should know the value of m. M is already there. And velocity of the electron has given here. You need to convert here. and the radius is the direct substitution here. Substitute the value of m, v, and r, and then calculate the what? Angular momentum here. 1 minute. Okay. What are the given data? Radius is 0.52 into 10 to the power of what? Minus 10 meter. Velocity equal to, what is the value of velocity here? 4 into 10 to the power of 6 centimeter per second divided by 100. Then it becomes 4 into 10 to the power of 4. Then the value of mass is known here. Next. Now I am substituting. Now what to be calculated here? Angular momentum of the electron. Solution. What is angular momentum equal to what? L equal to mv into r. Now substitute all the values of this. L equal to mass, velocity, and radius. Then finally you are getting what? This is the value. And the unit is what? Kg meter square per second. Of course, it is a direct problem. Here there is no need to scratch your head much. There is. Next problem. Calculate the moment of inertia of a uniform disk. Okay, this problem is related to disk. One should recall the formulas of moment of inertia related to what? Disk now. Of mass 200 gram. Mass is here. Gram. You need to convert it to kg. And the radius is what? 5 centimeter. Radius is given. About an axis passing through its edge and perpendicular to its plane. Passing through its edge means it is a tangent. It is a tangent. It is case 2. It is case 2. What is the case 2? Case 2 of the disk. This is the this is about this axis. It is a tangent and also what? Perpendicular to its plane here. What is the formula? I equal to 3 by 2 m r square. This is the formula. Now I will use it. Okay, mass is given. What is the value of mass here? The mass equal to what? 200 gram. You need to convert it to kg, and radius is now here. Next, moment of inertia. Moment of inertia about an axis passing through its center formula is what? 1 by 2 m r square directly. But we can write directly also. We can write here. Here. This one. How much it is? 3 by 2 m r square. Already I told you that is formula. In the examination, no need to write all these steps. No need to write. But simply just for your reference purpose, I've written here. This is 3 by 2 m r square. Next. Then substitute the value of this here. I equal to 3 by 2. Mass is there. Mass is how much it is? 0.2 kg is there. And then radius is how much? 0.05. It turns to be 7.5 into 10 to the power of 4 minus 4 kg meter square here. Okay. What to be calculated here? Moment of inertia. Problem is very simple. And sometimes they may ask you to calculate the torque, but of course, it didn't ask in the torque and all that. Next, fifth problem is a circular disk of masses. Again, this problem is related to the disk of mass. Of mass is what? 1 kg. Mass is 1 kg. Okay, in SI unit. And radius is what? 0.2 meter. Is making 120 rpm. That means omega 1. 120 rotations per meter about its diameter. Calculate the moment of inertia and energy. You need to calculate what are the things you need to calculate here. Now, first you need to calculate moment of inertia. And another one is energy, that is. The energy formula, what is 1 minute? Energy equal to, that is energy equal to of I into what? Omega square. Students, remember, this formula is related to what you can relate kinetic energy in linear motion. How you are writing? Of mv square you are writing, no? In rotational motion here, the mass is replaced by I and velocity is replaced by what? Omega. To calculate the energy, I need moment of inertia and also I need the what? Angular velocity. Of course, angular velocity is known here, but only your job is to convert in terms of what? Second and also in SI unit. And moment of inertia, you need to calculate. A circular disk of mass 1 kg and radius is 0.2 meter is making what? 120 rpm about its diameter. This is what we important. About its diameter means, I think it is, what is this? Third case it is, third case. About its diameter. See, about it. What is the formula? M r square by 4. This formula, I have to use it here. Now you need to calculate moment of inertia and energy. And now you say here, I equal to 1 by 4 mr square. Mass equal to how much it is? 1 kg. Radius is how much? 0.2 meter. Substitute all these things here. It becomes 0.01 kg meter square times. Next, omega equal to what? It is 120 rpm. Omega equal to what? Formula 2 pi into what? F. Students, normally you are doing the mistakes here. F nothing but what? How many oscillations, how many rotations it makes here? How many rotations it makes here? 120 rotations in what? 60 seconds. Here 60 into 2. Okay. Here that is equal to, then substitute this, it becomes a 4 pi. It is 2 into 2 pi equal to what? 4 pi. I know the value of phi. I know the value of omega. Then I can calculate what easily kinetic energy, rotational energy. What is the formula for the rotational energy? Is the rotational energy formula is of I omega square. I, you know that 0.01. Omega, you know that 4 pi square. Then it turns to be 3.392 joules. I told you in the beginning, the unit you can write either joules you can write, or else you can write in Newton meter. Both are what? Same only. Next. Problem 6. Calculate the magnitude of the angular momentum of the ball spinning at 10 revolutions per second. That is one, your cricket ball, you can say that. Solid sphere, you can say that. It is a solid sphere. It is spinning, that is. Just like how Earth rotates around its own axis, it is. Okay. 10 revolutions per second. As shown in the figure. Given, what are the given quantity here? Mass of the ball, calculate the magnitude of the angular momentum of the ball. What are the given quantity? Mass is given. And what are the radius is given? 12 centimeter. Problem, by reading this, one should have an idea. Ball is spinning means it should be connected. This problem is related to what? Solid sphere. It is what? Solid sphere is. Okay. For the solid sphere, you know the formula for that. 2 by 5 mr square. You know that. That is solid sphere. Sure. This is solid sphere. What is the formula for that? It is rotating about this axis. The formula is what? About this axis, IAB equal to 2 by 5 mr square. In the problem, has given the value of mass is given, the radius is given, then substitute and then calculate. Now, mass is now 6 kg. This mass is 6 kg. This is the 6 kg. And then radius is 12 centimeter. You convert into what? This. What is the rotational speed making here? F equal to what? 10 rps, of course. He is asking what? Moment of inertia. Moment of inertia equal to what? 2 by 5 m r square. Substitute this. 2 by 5 m means 6 kg. Radius is how much? Point dot. It turns to be 0.035. Unit you have to write here kg meter square and all that. Kg meter square. That's the unit is kg meter square. It is. Okay. But still problem is not completed here. Has given the F is given. Angular momentum you have to calculate. L equal to what? I into omega. L equal to what? I into omega. Next. The formula is L equal to I into omega. Omega equal to what? How much it is? 10 revolutions per second. This is. Okay, 1 minute. Okay. Now 10 revolutions per second. Okay. Then you convert it. Because we know the formula omega equal to what? Omega equal to 2 pi f. Omega equal to 2 pi into what? F. F nothing but rotations per second here. F nothing but rotations per second. It is 2 pi into F. It is 2 pi. F is how much? 10. Then it turns to be what? It is 2.2 kg meter square per second. This is the moment of inertia. Sorry, not moment of inertia, angular momentum. Last problem. How large torque is needed to calculate a wheel for which I has given 2 kg meter square from rest to what? 30 RPS in 10 seconds. Torque you have to calculate. What is the formula for the torque? Torque equal to I into alpha. Torque equal to I into alpha. Of course, in this problem, I has given this. What is the formula for the alpha? It is alpha equal to omega 2 minus omega 1 divided by t. Here, in this problem, you see, from rest means omega 1 equal to what? 0. But omega 2, you have to calculate. What is the formula for the omega? 2 pi into what? F. That you have to use it here. 2 pi into what? F and all. Now, yes, you see. Now in this problem, I has given omega 1 equal to what? 0 or omega not equal to 0. Or else omega equal to omega 2 you can write or omega you can write here. 30 RPS equal to 2 pi into 30 equal to what? 60. And what is the time here? 20 seconds. But alpha equal to what? 1. Alpha equal to torque equal to I into alpha. Alpha how to calculate? Omega 2 minus omega 1 by what? T. Then 60 pi minus of 0 divided by 20 equal to what? 30 pi. Then torque equal to I into alpha. What is the value of I? 2 kg. What is the value of alpha here? 30. It is 3 pi. That is 1 minute. 0. 0 get cancels. It is 3. It is not 30. This will be, it is this quantity. It is what? 3 pi. So that you multiply this 3 pi, then it turns to be what? 6 pi Newton meter. Now, with this here, read the problem always and recollect always before solving the problems or any one particular chapter, any chapter that is. First, you should list out all the formula you should list out, and also what along with what units. Then only it is easy for you to calculate the problems and all that. Students, remember always we can understand the concepts of physics only by solving the what problems we can. Only by solving the problems we can understand. Okay, I solved enough number of problems I solved here, but what are the formulas here? The formulas are what I told you here. It is torque equal to what? Very, very important formula. Torque equal to I into alpha. That is energy equal to what? Of mv square. But in rotational motion, it is what? Off into what? I omega square. Of course, I have not written here. This very important formula. Then alpha equal to what? Rate of change of angular velocity. Omega equal to what? 2 pi f. If in the problem he has given rotations per minute, then you need to convert in terms of what? Rotations per second by dividing by what? 60. Okay, my students. With this, by solving all the 7 problems, I end my session. If you have any queries, any difficulties about this chapter here, please share your send your doubts to the WhatsApp group. Thank you.